Oh, the cable I told you guys to bring out the other time. You took it in again. I bring it out. So number one, we have the inverter. Although this is a type of inverter, you guys can see this is a type of inverter, right? We are still coming back to types of inverter. Raise this one up. Also another type of inverter. That's also another type of inverter. That's also another type of inverter. So number one, we have inverter. Let me just leave them first. Then we'll come and I'll be showing you them. Number two, we have the jumper cables. This is jumper cables. Jumper cables. This is also jumper cable. I'll tell you where we use different types of this. This is also jumper cables. Number three, we have what we call the loop cable log. This cable log. This one that you see there. This cable log. Sometimes you might decide not to use it. This is number four. We have what we call DC cable. DC cable. This cable that we are using here to power our house. This cable that I said, this cable you are seeing now. This cable, DC cable. We still come to different types of DC cable that we have. How many have I given you guys? I gave you what? What's number one? Inverter. Number two, jumper cables. Number three, number four, DC cable. Number five, we have our inverter. We have our battery. This is battery. This is battery. This is another type of battery. This is battery. We have different types of battery. We are still coming back to this. So we have the battery. Number six, we have the battery rack. Can you see? This is the battery rack. This one is even a battery cage. Normally use this type, especially when you are putting your battery outside. If it's inside, there's another type that we use inside. There's another type we use outside. You're having a job this weekend. You guys are following. Next after that, we have what we call DC breaker. DC breaker. We have the DC breaker. Yeah, we have the DC breaker. Yeah, bring it. Is that one breaker or surge? Bring down. That one is surge. We are still coming to that. Can I move on?
Yes.
Number eight. We have our solar panel. Bring that panel. Bring it here. We also have different types of panel. Make sure I break for your hand. At least me, I'm looking for one. This is panel. We have what we call bus panel. What that is. Number nine, we have what we call DC surge. This is what we call DC surge. This one I'm holding. It's called DC surge. This class is ending by 5 minutes after 4. This DC surge. Everybody can see it. This one also have a separate function from breaker. Number 10, we have what we call A. We have AC breaker. We have AC breaker. Next, we have the solar charge controller, like the one that we tie to the wall here. We have a solar charge controller, like the one that we tie to the wall. We have the solar rack. So, solar rack, we still get to how to use solar rack. The solar rack is what we first install on the roof before what? Placing your rack. Hope you guys get what I'm saying. You put it on the roof before you place your rack. And I have some guys that will just tie the roof straight. Although it's not good, the roof might be linked. Can I move on? How many things have I given to you? Number one, inverter. Number two, jumper cable. Number three, cable log. Number four, DC cable. Number five, battery. Number six, battery rack cage. Number seven, DC breaker. Number eight, solar panel. Number nine, AC breaker. Solar charge controller. Then we have what we call knife changeover. or change over switch. Change over switch, like the one that we have here. Change over switch. So you can use it to change from maybe solar, maybe your inverter to your electricity, or you can use it for bypass. That's change over switch. I still have some other ones. If time permits me, I will talk about them. They're also breakers. They're also AC breaker. We have like single pole breaker, single pole breaker, under breaker, we have double pole breaker. Single pole breaker means it will only break one side. How many sides does your electricity normally have? Okay? And you studied electrical. It has three. You have earth, you have life, and you have neutral. So if it's a single pole breaker, it means you're only breaking what? The life. If it's a double pole breaker, it means you are breaking what? Live and neutral. We normally don't have three pole breaker because your earth should be what? Connected to the ground at any point in time, so that excess current flow down to the earth surface. Can I move on now? Next after that, I just listed all the components that makes up your inverter system. Next after that, we have some variables that you need to know. Electrical variable. I'm still coming back to those components later. In CCTV, you can just go to a site and say you need 4 cameras, outdoor, indoor. But in solar, you need to know what type of load that you want to carry. Load means the electrical consumption. So we have some variables that you need to know. Number one, you need to know your what we call the voltage. Number two, we have current. Number three, we have your resistivity. Number four, we need your wattage. Number five, you need your amps. Your current is measured in amps. Number five, you need your power. So under power, we normally have three types of power. Under power, we have three types of power. We have what we call what? Total power. We have reactive power, and we have what? Actual power. Your actual power is measured in wattage. So when you see the roads, maybe you are buying a TV and they say 120 watt TV, meaning that the actual load that TV will use at any point is what? 120 watts. But you can see an inverter, they will write 2.5 kVA inverter. When you see kVA, it means the total energy that inverter will generate is what? 2.5. Let me explain a better way power for you. Which one of you should go and buy a beer? I will show you. When you pour a beer, when you see a beer, a complete beer, what is inside? When you have a complete beer, you have complete beer inside a bottle, yes or no? When you now pour that beer inside the cup, what will you notice? There will be bubble, a foam forming upward, and what? A liquid downward. That liquid downward is what you actually drink, yes or no? Yes. That's your usable power. Are you getting what I'm saying now? Yes. There is no way you generate energy that will still be what? Energy loss. The form that is upward is what we call reactive energy. That is energy that will be what? Wasted. Whether you like it or you don't like it, so energy will be what? Will be wasted. Then what is inside that beer before you pour it out is complete energy. Meaning that if you have an inverter now that is a 2.5 kVA inverter, there is no way you can use the whole of that 2.5 kVA. That's the total that is generating. You can't use it. But if I have 2.5 kilowatt inverter now, I can use the whole of that 2.5 kilowatts because I know the actual energy that is doing what is being generated. Then the next one we have what we call power factor. We have power factor. Power factor is the ratio of your total energy to your usable energy. There is no way you will eat that you not go and visit the toilet. Yes or no? It means you use some energy. You do what? You pour some energy away. The ratio of the one that you use to the total that you have is what we call power factor. That's why you will see in some inverter, you see them writing a power factor of 0.8. And maybe when we get to the calculation, let me just give you a brief of the calculation. When they say power factor, if you have an inverter of 5 kVA inverter, it means the total energy that inverter is providing is what? 5 kVA. And now write power factor of 0.8. And you want to know the actual load that inverter can carry, you just do what? Multiply your total energy that you are generating, multiply by what? Your power factor. That will give you the maximum energy that inverter can generate. Hope you guys get what I'm saying.
Yes, sir.
So if you have a 5,000 or kVA inverter and the power factor is 0.8, what's the actual energy that the inverter is generating? You do your mathematics. You have a 5 kVA inverter, that is 5,000 kilowatt or 5,000 VA inverter, and you want to know the actual energy that inverter will generate. How much is it? That's 0.8 multiplied by 5,000. That's how much?
That's 4,000.
4,000. Meaning that inverter, that's why the fact that inverter is 5 kVA, a whole of 1,000 will be what? Wasted. Whether you like it or not. If the power factor is 0.9, how many energy will it generate? 4,500. Hope you get what I'm saying now. We are still coming back to it too. Then the next one that we have what we call amps hour. Amps hour. That's the ratio that we use in calculating our battery. Check this battery now. Somebody should help me with this. This battery they wrote 200 amps hour. This one they wrote was 65 amps hour. Meaning that the power is energy multiplied by time. Meaning that the total power that this battery can accommodate is what? In class 65. Let me explain it this way. So if I want to use this battery on a load of 10 amps, how many hours would this battery last? The total power that this thing will generate is 65 amps hour. And now I'm now using on 10 amps. How many hours would that battery last before it collapses?
That's
6.5 hours. Although we are still coming to depth of charge later. Meaning that if I put 10 amps load on this battery, after 6.5, assuming this battery is truly 65 amps battery, after 6.5 hours, I want 6.5 hours. 6 hours and 30 minutes. Don't forget, people used to make that mistake. So if you see 6.8 is around 6 hours 42 or 45 minutes. If you don't get this calculation, you and your clients will just be having problems. Because your clients will ask you how many hours can your inverter use. Hope you get what I'm saying. So that's on it. So the power is the number of energy that it will use multiplied by what? Time. And that's the energy that will save either your battery or the energy that you dissipate over time. Abi, there's no load that you do that you will not use with time. Let me shock you one very funny thing about engineering. Do you know that when you are carrying load, you are not using any energy?
Yes.
So if you are carrying a bag of rice on your head like this, you are not using any energy. It's a potential energy. So you just sweat because force, you are just exerting force. It's until when you move. So when there is a move of current, that's when energy starts working. Hope you guys get what I'm saying now. Although we also now put this one down. For every inverter, we now have what we call idle energy. Idle energy, you will notice that there are sometimes, put it back and go around this. There are sometimes you plug an inverter and your clients will say, Oga, we don't use waga. Oga, and that inverter, we don't even use it at all. We just put it. There's an idle energy that you will use. If you don't put any load on this inverter now, and now put it on, permanently on, after some time, what will happen? We still drain the whole battery. Because we have idle energy. Energy that is being used by your inverter before you add any external load. Hope you guys get what I'm saying now. Can I move on now? So this class is 1 hour 30 minutes. I will now move to the next phase. We have load. Load are what? What? What's the load? Electrical engineers. Devices that consume your electricity. I'll put it this way: we have three major types of load. Although there's nothing like an ideal load, we have three major type of load. I'm now under load though. I'm still coming to inverters though. But until when you understand this thing, that's what will determine your setup. We have what we call resistive load. Like this bulb now. This bulb that you see here. This bulb that you see up here is a resistive load. And what is the major characteristics of the resistive load? It consumes almost the same energy with respect to time, and its manner of behavior is like a resistor. Hope you get what I'm saying now. The moment if this light is 10 watts, it will still consume what? Utterly almost what? 10 watts. And it maintain that 10 watts throughout the point of usage. That's resistive load. That's what. One. It behaves like a resistor. You have a question? No. We are still coming to DC. I'm not yet even on DC or AC. Number two, we have what we call inductive load. Let me bring this one. I'll put that light. Thank God we are using the only thing that we are using is what do you notice about this?
That will start off power.
Number one inductive load is that it has what we call start-off power. When you first put it on, no battery. When you first put it on, it will what? Consume more energy than the energy that we use throughout. Number two now, its energy usage varies with time. The energy usage varies with time. So at time T, you have different energy. At time one, you have different energy. The energy is going up and down as that fan is rotating up and down. That's the same way the energy is going up and down. Although you have a relative energy that you'll be using, they can tell you that this fan uses an average of let's say 300 watts or let's say 150 watts. That 150 watts will not be what? Will not be constant. It will be going up and down. The more you plug it first, it will consume more than 150 watts. When the startup energy might be like around 180 or 200 watts. Hope you guys get what I'm saying. For those of you that do not study engineering, just put it at the back of your mind that any device that you have that have coil inside, put it down like that. Any device that you have that have coil, what is inside this thing? Any device that you have that has coil inside is what? That inductive load. Because it's that coil that will generate the inductor. And that's one of the major problems that some of our guys make mistake. When they calculate, let's say the man said, I want to use 10 fan in my house. Let me just put it at 10 fan. 10 times 200, that's 2,000 watts. So people now go and do what? They go and buy 2,000 watts inverter. By the time you now plug all the 10 fans at the same time, what will happen to that inverter? It will trip off. Because it will need more than that 200 watts per one to do what? To start up. Hope you guys get what I'm saying, sir. Number three now. Under load. We have what we call capacitive load. So you need to know the nature of the load that your clients, the major ones. You know, you have some clients that will tell you that in my house, I just want to put on my lighting points and my what? TV with DSTV, I'm okay. Are you guys with me now? And you have some clients that will tell you that, okay, come, I want to AC on my inverter. Capacitive load now. In a layman term, any load that the major component that is there is a capacitor. A good example of a capacitive load are normal AC. Abi, ṣé normal AC ò ní capacitor ni? Tube television, those olden days television, and have this at the back of your mind, except for inverter AC, normal capacitive load, some of them need twice their energy rating to start up. Hope you guys are with me. So if they put it on an AC now, you want to buy an AC, an average 1 horsepower, a normal AC 1 horsepower will consume 1,800 watts. Some are 1,500. That 1,500, that's the wattage that the AC has. But for you to start up that AC to start working, it will start with what? Consume 3,000. And still some are at 1.8. It will consume like 2,500. That's why most times when you put an AC on an inverter, if your calculation is not wrong, what will happen to that inverter? It will trip off. Same with some olden days fridge, some freezer as well. Because they have capacitor, the condenser is a form of a capacitor. The behavior of that condenser is like a capacitor. So the moment the condenser wants to pick up like this, it what? It draw more energy. And if you don't put that allowance when you are designing your inverter, you might end up doing what? Refunding the money of your claim. Because imagine somebody that told you that I want to put two AC on my inverter, and they plug one AC, that one is working, and they want to plug another one, the inverter is tripping off. Another good example of a capacitive load is your microwave. Although microwave combine both capacitor and inductor. Let me now tell you now, I've given you the theory. There is nothing like an ideal load. A load we have both inductor, most load we have both inductor, capacitor and resistor, yes or no? But one will be more dominant than the others. Hope you guys get what I'm saying now. So before you even give your client estimate at all, you need to know what the types of load that are available there. And what we normally do is that you do when we are doing load estimation, we still get to load estimation. You need to do what? You write serial number followed by what? Items. Next one is the type of load that it is. So you need to